link. Hello friends, welcome to our lecture. Hello students, welcome to our today's video. Today we will discuss about relations and functions. In our last video, we discussed about the introduction of mathematics of class 12th. Today we will continue and start our first chapter, which is relations and functions. I hope you have seen the last video. In that video, I discussed that for learning the mathematics of class 12, we will require many topics which we have already studied in class 11th. So let's begin with our first topic. Students, you know that we have studied in class 11th. We have studied in class 11th sets in first chapter and relation and function in second chapter. So what we are going to do now, we will start with our chapter, and I will first of all recap all the topics of class 11th which we will require to study this. If you have studied in class 11th, your concepts are very clear, then that's very good, because we are going to use those concepts. But if because of some reason your concepts in class 11th of sets, relation and function are not clear, then there is no need to worry, because I will start with very basics from class 11th. We will discuss first of all basic concept of class 11, then we will build our concept of class 12 and then continue in this. Now what we will do, let's start our presentation. First of all, recap of class 11. Let's see which chapters we will require, which topics we will require, and then start with them. First of all, you must have studied sets. What are sets? You studied in class 11th what are sets. A set is a well-defined collection of objects. Now in this definition there are some keywords. First of all, first keyword is well-defined. And what do you mean by well-defined? It says if you want have a number of objects and you want to classify them as a part of set or they are not a part of set, then what will you do? We should have a proper definition that if I will pick one point element, if that object satisfies the definition, I will put that object in set, and if that object is not satisfying the definition, then I will put it out of the box, out of the set. Now you must know this. Then sets are denoted by capital letters. We know that if I want to represent a set, I will represent it by capital letters A, B, C, T, L, whatever you want depending upon your context. Now if I want elements, how do we write elements? If there are elements, I will represent them by their small alphabets. What do you mean by that? Small letters. And small letters with A, B, C, and that we are familiar with this notation. These notations are standard, we are using in mathematics this way. Now let's go further. How do we represent the sets? There are various ways in which we can represent a particular set. You have studied in class 11th the first way of representing a set is roster or tabular form. Here in my screen I have, you can see the set of vowels, and in roster or tabular form I have written it in curly brackets A, comma E, comma I, comma O, comma U. I have written all the elements in the set in curly brackets. This is the representation of a roster or tabular form. Then I have a second type of representation of sets, that is set builder form. I will say, you know that there are a builder, a architect, he builds so many buildings. No, what we say, we can represent by the single builder. We can represent all the buildings built by a single builder. If I mention the name of the builder, see, this is the name of the builder and he built all these buildings because he is the common factor of those buildings. Similarly, in set builder form, what I write the definition which is taking place in our set, which is classifying elements of our set. As if in our example, I have written X, such that means all X will be in the set such that X is a vowel in English alphabet. All those alphabets which are a vowel and in English alphabet, they will be included in this set. This is set builder form. Then there comes Venn diagrams. And what are Venn diagrams? We know that Venn diagrams are geometric representations of sets. In these, what we do, we build a circle or a box and mention all the elements in that circle or box. We'll write them simply. I will at the end, I will tell you a very interesting thing about Venn diagrams, that why we call these diagrams Venn diagram. Is there any reason or it is just like that? We will discuss it later. Okay, now let's go. Then we will talk about empty set. The name empty set tells itself about it. Empty means when there is nothing in it. So let me tell you the definition. A set which does not contain any element is called the empty set or the null set or the void set. I have given an example. Set A contains X such that X is greater than 1 and X is less than 2, means all numbers between 1 and 2. And then I give another condition, X is a natural number. Is there any natural number which can lie between 1 and 2? This is not possible. So this type of set is empty set. One thing we should notice that when you talk about an empty room, we say there is no person in that room, but we will mention the walls of that room which are containing that space. Similarly, when we are writing about empty set in roster form or tabular form, we will write no element because there is no element, but we have to make the walls, the curly brackets, to show that it is a set, and when there is nothing between those curly brackets, it represents that it is an empty set. We also represent it by a Greek letter phi. Now, you also know about finite sets and infinite set. As the name says, finite set, a set which is empty or consists of a definite number of elements, is called finite. But if the set contains infinite number of elements, it is called infinite. Let's have some examples. First of all, set of the days of week. You can count the elements in this set. Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday and Sunday. There are 7. So there is a definite number of elements in this set. That's why it is finite set. Similarly, set of all natural numbers. 1, 2, 3, 4, 5, 6, 7. Even I can't stop my counting. So there is no definite number of elements in this set. So it is infinite set. Now let's go further. Now we will talk about equal sets. Two sets A and B are said to be equal if they have exactly the same element, and we write A equals to B. And what does this mean? Let's take an example. As A be the set of prime numbers less than 6. What are prime numbers less than 6? I have 2, 3, 5. This is set of prime numbers less than 6. Then I have another set B. It says B be the set of all prime factors of 30. Now what are prime? First of all, let us check what are the factors of 30. 1, 2, 3, 5, 6 and 30. But out of these factors, which factors are prime? I have written I have 2, 3 and 5 are prime factors of 30, but 1, 6 and 30 are not prime factors. So in this case, it is very easily visible that set A and set B have different definitions, but the elements in them are exactly equal. Set A is equals to set B. If two sets are not equal, we will represent it by A not equal to B. Now let's go further. Now let's talk about subsets. What are subsets? A set A is said to be a subset of a set B if every element of A is also an element of B, and we denote it as A subset of B. This is the symbol of subset. Now let's take an example. Set of natural numbers is subset of the sets of integers. I have a set of natural number n equals to 1, 2, 3 and so on. Now I have another set z which has all integers 0, then positive integers 0, 1, 2, 3, 4 and then negative integers -1, -2, -3 so on. Now you can easily see that all natural numbers, or I can say all elements of set n, can be seen in set z, that is the set of integers. So I will say n is a subset of z. Similarly, we can have many other examples. Let's take an example. If I say a set S which represents all students in class 12th of your school, S, you can remember. Then I talk about another set B. B represents all boys in class 12th of your school. Now you can easily comprehend that set B, the set of boys, is the subset of all students in your class 12th in school, because all boys are obviously the students of class 12th. Now let's go further. We will talk about power set. What is power set? We discussed in earlier slide that what is subset. Now for a set there can be many subset. As if in our earlier example, the set was set of all students in your class. Now I am giving some examples of subset C. First, set of all boys in class 12th in your school. This is also subset. Set of all girls in your class 12th in your school. That is also subset. Set of students whose name start with A. This is also subset of your previous set. Similarly, there can be many subsets. What is power set? Power set of a set contain all possible subsets of a set. The collection, now I am reading the definition, the collection of all subsets of a set A is called the power set of A. It is denoted by P of A. Now let's take an example. For A equals to 1, 2, I have a set with elements 1 and 2. What will be its power set? Or I will say what can be its subsets. First of all, there can be an empty subset, a subset which contain no element. Then I can have a subset 1 which contain only 1. Then I can have a subset 2 which can contain only 2. And then I can have a subset 1, 2 which contain all the elements of set A. Now I compiled all these subsets in another set. There you can see curly brackets in starting and a curly bracket in end. It means I draw a wall on the sides of these sets. I contained them in a room, in a set. This bigger room, this bigger set is called power set of set A. Now let's go. You know what is universal set? The name depicts that universe. When you talk about planets, persons, solar system, galaxies, and then you think of universe. Universe is something which contains everything you can think about. Similarly, in our theory of set, universal set is a type of set in particular context. I am mentioning it. In a particular context, the set containing all sets under study is called universal set. As if I mention, I am discussing about various sets like set number 1, set of all boys in your school, set of all girls in your school, third, set of all students in class 5th, fourth, set of all students in class 2nd, next, set of all students with science stream, set of all students with who are studying Hindi. There can be many sets, but you can think if I say a bigger set, the set of all students in your school, you will easily see that all earlier set can be contained in this bigger set. So for this particular context, my last set, the set of all students in school, will behave like a universal set. Next, union of set. Union word says something combining. Correct? So what is union of set? It says when I combine two sets collectively, that's union of set. What definition says? A union of two sets A and B is the set C, which consists of all the elements of A and all the elements of B, the common element being taken only once. What it means? Let's take an example. I have set A which contains 2, 5, 3 and 7. Similarly, I have another set B which contains 5, 7, 8, 9. If I want to find the union of these set A union B, it contains 2, 3, 5, 7, 8 and 9. You will see the element 5 was in both A and B. So I written it only once. Similarly, 7 was in both set. I have written it only once. Then element 2, element 3 were in set A, so I have written them in union. And element 8 and element 9 were in set B, so I have written also them in this union. Now let's go further. What is intersection of sets? But what this word intersection means? Now let's think of two lines are passing, and when I say intersection of two lines, the image in your mind will come is a point at which both lines meet, or I can say the point which is in both of the lines is called the intersection. Similarly, intersection of set means those elements which are in both of the sets. What definition says? The intersection of two sets A and B is the set of all those elements which belong to both A and B, common elements. The symbol this intersection is used to denote intersection. Let's take an example. Set A contains 2, 5, 3, 7. Set B contains 5, 7, 8, 9. So what will be the intersection? I will check the common elements. 5 is in both sets, so I will take 5 in intersection set. Then 7 is in both sets, so I will take 7 in intersection of sets. No other element is in both set A and B, so there are two elements in set A intersection B. Next, complement of set. What complement of a set means? If I have a universe, and in that universe, let's take start with an example. I was talking about all students in your school. In this all students in your school, I take a set of all boys in that school. Now what if I remove all the boys from school? You will say there is another set which remains there, the set of all girls. You know? So this set, the remain set of all girls is complementary set of set 1. Or I can say in the same universe set of all students in your school, I have a set B, which means all students of class 12th. What it means, what will be the complement of this set? It includes the complement of set of class 12 students will be students of class 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11. It means all other remained elements. What definition says? If U be the universal set and A be the set of U, then the complement of A is the set of all elements of U, which are not the elements of A. Take an example. U. I take a universal set for 1, 2, 3 until 10. I take a set A which contains 1, 5, 7, 6 and 7. What will be complement? Just remove 1 from the set, remove 5 from the universal set, remove 6 from the universal set and remove 7 from the universal set. Which elements will be remained there? Elements in complementary set will be 2, 3, 4, 8, 9 and 10. Done. Now let's go further. Now we will talk about Cartesian product of two sets. Now slowly we are leaving the concept, starting from the concept of 11, we are entering very slowly in concepts of class 12. So be careful, be attentive, be concentrated, because this is the starting. I am starting with Cartesian product of two set. This is the base starting of class 12, which this will be required in all definition which we will study in class 12 this chapter. What is Cartesian product of two sets? Let's take the definition. Given two non-empty sets P and Q, the sets must be non-empty. The Cartesian product, represented by P multiply Q, is the set of all ordered pair of elements from P and Q. What does it mean? We will see it further. Then take the mathematical notation of Cartesian product of set. I write P multiply Q. Here these are capital letters, so I am multiplying the sets. And what it means all ordered pair. I will make a pair P comma Q. I made a pair. See, ordered pair. What it means? Pair means pair of two elements. Now what is the meaning of ordered? Order says P comma Q and Q comma P are two different elements. It means the order of elements matter. This is point one. Now let's continue. The elements in the Cartesian product will be of form P comma Q, where P belongs, smaller p means element. This element belongs to the first set capital P, and the second element small q of the pair belongs to the second set capital Q. Now let's take an example to clear this concept. I started with this. You know, in this our YouTube channel, we are teaching, let's suppose 3 subjects today. You know, physics, chemistry and mathematics. And we have 3 time slot which you have received in your messages or PDF. First time slot is I make a set of subjects as physics, chemistry and mathematics. I made another set of time slots which are available, that is 10 to 10:50. Second time slot is 11 to 11:50 and third time slot is 12 to 12:50. Now what are the possible arrangements of subjects in time slot? Which subject can be taught in which time slot? All possibles. How can we know this? We will find Cartesian product of these two sets, set S which represents subjects and set T which represents the time slots. What are possible? The Cartesian product will be as follows. Physics can be taught in first slot of 10 to 10:50. Physics can also be taught in second slot 11 to 11:50, and physics can also be taught in third slot 12 to 12:50. I am checking the possibilities. Now same case can be possible with chemistry. Chemistry can also be taught in first slot of 10 to 10:50. Chemistry can also taught in 11 to 11:50 slot, and chemistry can also be taught in the third slot 12 to 12:50. Now same case can be possible with mathematics. Mathematics can be taught with 10 to 10:50. Mathematics can be taught in 11 to 11:50, and mathematics can also be taught in mathematics in 12 to 12:50. Now you can see what is this Cartesian product mean. I can calculate, I can see all the possibilities in the relation, the pairs of the elements of two set. Now in this Cartesian product, we covered all the possibilities that which subject can be taught in which time slot. So that's very useful for us. We can see all the possibilities which are we can use. Now, Cartesian product of a set with itself. Till now we studied about two sets and we find the Cartesian product of them. Is it possible to find the Cartesian product of a single set with itself? Yes, it is also possible. As if I take a single set A which includes 1, 2, 3. The Cartesian product will be the Cartesian product. A multiply A. I am multiplying it with itself. Now I will take A with A. Now what are possibilities? Possibilities is 1 can be related with 1 itself, 1 can be related with 2, and 1 can be related with 3. 3 possibilities I checked for 1. Now what about 2? 2 can be related with 1, 2 can be related with 2 itself, and 2 can be related with 3. There are, you can see 2, 1, 2, 2, and 2, 3. Similarly, the third 3, 1, 3 can be related with 1, 3 can be related with 2, 3 can be related with 3 itself. These are the 9 possibilities. Now you can see I have 1, 2 as a separate element and 2, 1 as a separate element. This is the use of term we said ordered pair in our previous slide. You can see that. What was the definition of Cartesian product? P cross Q is the set of all ordered pairs of elements. Means there must be a pair, but those pairs should be in order. The order must matter. Similarly, that's why we take 1, 2 and 2, 1 in different elements. Now let's go further. What is relation? Now we are gradually coming to the class 12th topics. But you have studied this at the end of the topic of relation and function. What is a relation? I want to discuss this a little in explanation because this is very important conceptual thing. What are relations? Just think in real terms. If I ask a normal guy who never studied maths in 11th or 12th, a student, I ask him what is relation? Give me an example of relation. He will say brother, sister, father, mother, friends, all these are relations. And he's absolutely correct because all these are relations. But why are we studying in mathematics? Are these type of relation in mathematics? In mathematics, we have a really little different type of relations, as if less than, greater than, equal to, less than equal to, and so on. For example, I can say I have two friends in my class, that is Vishwadeep Singh and Yash Tiwari. Now they are friends. What will I say? Vishwadeep is friend of Yash. So the relationship between them is friendship, and the elements are Vishwadeep and Yash. Similarly, I have two more students, Shivansh, Shivam, Amitesh. They all three are friends. Similarly, in this case, I have again relation is friend. I will say Shivam is friend of Shivansh, Shivansh is friend of Amitesh, and so on. Similarly, we have relationship in mathematics. If I talk about numbers 1, 2, 3, 4, our relation is less than. Now you can say 1 is less than 2. So 1 and 2 are related by the relation less than. 1 and 3. 1 and 3 are related by the relation less than. Now all elements are not related in all terms. Now if again I am say again I will talk about two students in my class. I have Prabhu Raman Mishra and then other is Abhishek. Now they are friends but they are not brothers. I will say, is there a relation? I will say in that relation, friendship. I will talk about brothers. Is Prabhu brother of Abhishek? You will say no, because they are just friends. So in this case, between them, the relation of friendship is okay because they are friends. But the relation of brother is not correct in this. So all elements don't satisfy all relations. Now let's get to the definition part of relations. A relation R from a non-empty set A to a non-empty set B is a subset of the Cartesian product A cross B. Now, where from this Cartesian product came, we will understand this later. The subset is derived by describing a relationship between the first element and the second element of the ordered pair in A cross B. Means the relationship between first element and second element. This is like this. Now the second element is called the image of first element. Now if I say Vishwadeep is friend of Yash, so my pair will be Vishwadeep comma Yash. So Yash, the second element will be the image of first element, that is Vishwadeep. Now let's go further. Let's take some examples to understand the concept of relations. Let's take a set A1, 2, 3, set A. What will be the Cartesian product? A cross A. That is 1, 1, 1, 2, 1, 3. Then 2, 1, 2, 2, and 2, 3. Then 3, 1, 3, 2, and 3, 3. These are the all possible pairs. This we including Cartesian product. Now I define a relation. As you said in earlier case, I defined relation of brothers, friends. Similarly in mathematics, we have to firstly start with the set for whose elements I am talking, and then I have to define a relation. Similarly in maths, I define a relation R. First number is less than second number. This is less than is my relation. I can write this relation in other form, A R B. We will read that A related to B. And what a relation is? A is less than B. This is my relation. There is another form of writing a relation. R equals to means R includes those elements and it will include in terms of pairs A comma B. All A comma B will come in this relation if such that means I am starting giving conditions. What is my condition? A is less than B. A pair A comma B will be in this relation if A is less than B and A comma B belongs to A. Now let's start. Take from first 1, 1. Can you put this in here? 1 is less than 1. No, 1 is not less than 1. So I can't put this pair in this my relation. Leave it. Then I have 1, 2. 1 is less than 2. Yes, it seems correct. So I will put this pair in my relation. I write 1, 2. Then third element 1, 3. 1 is less than 3. Yes, this is also correct. This seems correct. I will put this in my set of relation. Then I have 2, 1. 2 is less than 1. No, this is not correct. So I can't put this pair in my relation. I leave it. Then 2, 2. 2 is less than 2. No, this is also not correct. Then 2 is less than 3. Yes, it is correct. Very good. I will put this pair and in our relation. Then we'll check further. 3, 1. 3 is less than 1. No, this is not correct. Then 3, 2. 3 less than 2. No, this is not correct. And 3, 3. 3 is less than 3. This is also not correct. So I will not put these elements in my relation. You will see in my relation, I put all elements from Cartesian product. So I can say the elements which are in relation are also in Cartesian product. Now from the definition of subset, you can say that relation between sets is a subset of Cartesian product because all elements in a relation come from Cartesian product. Now with this example, recall the definition. Here we said earlier a relation R from non-empty set A to non-empty set B is subset of Cartesian product A cross B. Now you must be clear why I am saying subset of Cartesian product, because Cartesian product contain all the pairs of elements and relation contains some selected pair of elements, and these selected pair of elements came from the Cartesian product. So I says that relation is a subset of Cartesian product. Very good. Now let's move. Now I'm taking a quite interesting example. Just please check it. I take a set of selected international leaders. I selected some international leader and representing this set by L. First leader is Narendra Modi, then Donald Trump, Vladimir Putin, and Xi Jinping. You know all these. Then I take another set of selected nations. I selected India, USA, Russia, China, and Pakistan. Okay, now possible pairs of leaders and nation. I want to check all possible pairs. What will you do? We will calculate the Cartesian product. Very good. Now I paired Narendra Modi with India, first leader with first nation, then Narendra Modi with USA, second. I will pair Narendra Modi with all nations. Narendra Modi Russia, Narendra Modi China, Narendra Modi Pakistan. Now it comes for second leader, who is Donald Trump. Donald Trump with India, Donald Trump comma USA, Donald Trump comma Russia, Donald Trump comma China, and so on with Pakistan. Now it comes for Vladimir Putin. Vladimir Putin with India, Vladimir Putin with USA, Vladimir Putin with Russia, and Putin with China, Putin with Pakistan. Then it comes for the last leader, Xi Jinping. Xi Jinping with India, Xi Jinping paired with USA, Xi Jinping paired with Russia, Xi Jinping paired with China, and Xi Jinping with Pakistan. There are no any other ordered pair in this possibility. I included all these. Okay, so this is the benefit of Cartesian product. Now let's go further. Something interesting is going to come. Now it defined a relation. Leader visited in 2019 a nation. I collected this data from Wikipedia that which international leader the selected visited which selected nation in 2019. I found some results, and how can I represent this relation? My relation is leader visited in 2019 nation. I can represent in second form L related to N. When I will write this, when L visited in 2019 N means nation. Another form of writing relation as a set L comma N. All those pairs will be included in this relation if such that I am giving a condition. L visited in 2019 N, and where L the element belongs to L, the set of all leaders, and small n the element belongs to capital N, the set of all nations. Now I am telling the what happened in 2019. These are real data. In 2019, Narendra Modi visited USA. So there is a pair of Narendra Modi comma USA. Narendra Modi also visited Russia. So there is a pair of Narendra Modi comma Russia. Narendra Modi visited no other nation from our set in 2019. Now Vladimir Putin visited China. You will say, where is Donald Trump? Actually, Donald Trump neither visited India, USA, Russia or China in 2019. So there is no element. So Vladimir Putin visited China, that's it, only single nation. And Xi Jinping visited Russia in 2019, and Xi Jinping also visited India in 2019. So for this relation, leader visited in 2019 nation, in this relation following pairs are selected out of my Cartesian product, the whole set of possibilities, and this will be represented as the my relation. So these are the four ways of representing a relation. You can see. I hope you understood. Next, domain of relation. What is domain of relation? Now you will see I started with my first set was the set of leaders, and then I made their image on the set of nations. So the set of all first elements of the ordered pair in a relation. The first element in relation, the pair are there, the first elements are from set A to the set B is called the domain. The first elements of the pair are called the domain. The set of first elements of pair is called the domain. As if for me, Narendra Modi, Donald Trump, Vladimir Putin and Xi Jinping, from which I started with first. These are the domain of relation. Then what is range and codomain? The codomain is the second set on which I am mapping the images. the second element of the pair. In this case, we had the nations. So my codomain will be India, USA, Russia, China, and Pakistan. The set of all second elements in a relation are from a set A to a set B is called the range of the relation. What is range? Now we will see no one visits Pakistan. So for all the in my relation, the pair, this Pakistan was not the second element of any pair because no one visited the country. But some people visited India, some leaders visited USA, some leaders visited Russia, some leaders visited China. So these four countries were image of some leader. So that's why we will include them in range: India, USA, Russia, and China. Now one thing you will notice that codomain is a bigger term. All nations in the second subset will include, but range is a smaller subset of it, because range contain only those elements of codomain which are image of some element in domain. I am repeating my statement about range codomain. I will say range includes only those elements of codomain which are image of some element of domain, as we can see. So range is always a subset of codomain. Range can be equal to codomain and cannot be equal to, may not be equal to codomain. This is depends upon the possibilities. Okay. Now, today we repeated all the possibilities, all the topics of class 11th which we used. Now let me give you some what we will do in next video. In next video, in next lecture, which is on Wednesday at 12 noon, on 22nd of April 2020, we will discuss about types of relation. How many type of relation we can have. We have completed the recap of class 11 topics. We understood the concept basically. How will we use them in our this next class 12? So next time we will discuss type of relation. Let me give you just a recap. What we will do, we will discuss about empty relations, universal relation, reflexive relation, and so on. We will take some good interesting examples, and till then, I suggest you what? In next lecture, take a copy and pen with yourself when we are watching video, because next time I will give you questions live on this screen, and you will tell me the answer of those questions in comments, and we will check who is correct and who is not. So that is very good, beneficial, and so do this and take a copy pen next time. If you have a book of 11th, revise all the topics because we are going to use them in class 12th mathematics. So this is from my side today. Thank you for watching. Thank you for giving your precious time. And if you have any query, any problem, just after this live stream, this video will be uploaded on the channel itself, and you can comment on this and comment your queries, your questions, your problems freely, free-mindedly. And if you have any question, you can send it in comment. We will discuss in the next